Alright, hello. Let's continue. Currently reworking a little bit of the kind of like the dereferencing of locations, and so yeah, doing a little bit of cleanup on how we're passing like locations around. And what I'm thinking is that I just added this dereference bool here, and so the idea is that if this is true, then the location this refers to is gonna be kind of forwarded by the location that it originally referred to, which is this thing here. And then if you have a mod, the question is, will it modify the original, like this location, or the result? Now, I'm pretty sure it's because it's like if you do a lookup and you do like an add one, like you have an address add one, it's probably the address you want to modify. And then if you need to further modify the result, then we could do that as well, using like the add instruction. Yeah. So that's the idea here. And I was just checking because before we had like a scope option here, like you could have a scoped variable, but I realized that that's not necessary because the declarations are actually happening like that's all in the compiler, so we don't need to send that off as like a type of location, because we basically just say that okay, we are compiling an expression and we're declaring that in the result of that into the scope, which is then here declared in that scope. And then when you refer to that thing, it's actually in the compile identifier, so then we look up that binding based on the identifier name. So it's like we don't really need an instruction to refer to like a variable, because that is all gonna be like resolved anyway here. So yeah, so that's that is how that is. Yeah, and where did we go? Where are we? Right. So my idea is that maybe the idea is that if we could get this to be kind of serializable, then that means that now all instructions and all values are serializable. So that means that we can actually have this language be written out in, kind of like an intermediate format as well. So that's the goal here as well, to make this serializable. The ref is serializable, although it has a name. So what this is kind of like a relative stack based location. So it's like it has a relative stack address. So what that means is that when this is used, it's gonna be this current stack frame plus whatever this stack address is. So that is what that is. And then you have obviously just the stack. We have the heap location types. we have the register. Now the thing is, like, all of these could probably be like absolute, well, not absolute, but basically just numbers. However, the thing is, well, except for register, I guess. And the instructions are kind of interesting as well, because the instructions here are not like part of the memory, so to speak. It's like in its own kind of list of lists, basically. And then we have the read-only data, which is also, it is actually part of the memory, like mapping, like we map like a usize domain to read-only memory, the heap, and the stack. So there's that 3 parts that we're mapping, like an address in the usize domain to those 3 things, which basically is saying that we have data, stack, and heap are kind of sharing the same space. So they can never have the same address, let's say. But then we have the registers. Of course, they are different. They are special, and they have their own location. And then we have also the instructions, which also have their own location. But that's fine, because instructions that refer to other instructions, they are also kind of, we know that it refers to an instruction and not a, a data memory address, like it would be in assembly. Like in assembly, it wouldn't be any difference between like an instruction address and some kind of data address. It's just a number that shares the space as well. Although I'm not sure if you can probably maybe set up like virtual spaces or something. I don't know. Anyway, like nowadays with the fancy stuff. But yeah, so now actually this should all be kind of serializable actually. Instruction address is just 2 numbers. Well, it's 1 number, and then we have like this thing here. Oh yeah, labels are one thing that is not known at all times, because you can define a label and then refer to a label without it actually having an address assigned to it yet. But once everything is compiled, then all labels should be kind of populated or resolved into where they should be. So that is like, I think this is like the one thing that we cannot actually, well, I mean, we could serialize it because we can just excuse me, the key is counter and name, right? Yeah, and then we just serialize it like this, I guess, like the name and the counter. So counter is kind of like the ID of the label, and the name is just to make it easier to see what label it is for the humans. Okay. Yeah. So that is the instructions. Okay, so yeah, and then the register is just an enum referring to any of the 4 current registers that we have. Okay, now, yeah, so the issue that I'm trying to solve is that when you have a location that you're trying to set, like using the set instruction, for example, but you also want to like you don't want to set you want to dereference, so you want to set the thing where the address is that you want to set. So we have, where is the bindings? So here, for example, we have a ref, and the ref is basically, it's a stack. It's like a push with a label. So this creates a thing on the stack with this label. Okay, and then we can use that ref to we can refer to the ref as a location, and if we set the location itself, we're setting the stack location to whatever value we want to have here, right? But the idea is then that we could also potentially like deref, and I will have this notation for dereferencing this, and then suppose that this contain like an address, then that's gonna get dereferenced. We're gonna grab whatever's in the address and set that. We're setting that location to this. So that's the idea, because then we can support, you know, this expression here, which refers to, well, we take the stack frame plus 2 and we dereference that, set it there. Yo, buffer, what's up? That was the bootloader sequence. Welcome back. And the other thing was here, when we set something to a result that is also dereferenced. So this refers to the stack frame, or yeah, the stack frame plus whatever, or yeah, the stack value, the content in the stack that this refers to, and then this would dereference that because that is an address, but this contains an address, so we dereference that. Now we're grabbing the value at that address, because otherwise we would just get the address itself if we didn't dereference. But now we get the contents at that address and we populate R with that. However, this is wrong. I just realized, like, if we do this, like, there's no way of getting, like, we would want to be able to get the actual address of this stack value as well. So this would probably set it to the stack value, actually, like, or the address of the stack value. Yeah. So so if we dereference, now we get the contents, yeah, of the stack at that point, at that address. Yes. So this is kind of doesn't really make sense. This is kind of saying that, hey, I want to set this. I mean, it should really be this, I think, because otherwise we're kind of setting this pointer to something else, is what I'm thinking. But that is not really possible, because this is like a ref. I'm just gonna do this to have the notation the same, because it's kind of weird if this is gonna be something different. But yeah, this is gonna be the notation here. Okay. So actually, if we go to our location here and the format function, and we'll say that no, let's do that. And we'll compact this a little bit. And then we don't have these. And what we do is we say if we are dereferencing, then we're gonna print, or we're gonna write this thing, and we're also gonna do that. So that's that. Okay. I just need to plan this a little bit, because whenever I try to kind of just wing it, I'm painting myself into a corner. So I have to look through here a little bit and to kind of see what we need to do and make it make sense. So this is setting the R register to the content of this pointer, which is slice.address. Yes. So you can kind of think of this as a pointer to slice, and then dereferencing would get the first field, which is address. But then, okay, so what if you want to get the length? Let's just have a hypothetical thing here. So this would be the stack, a stack pointer, and we just add 1, and now we're setting, this would be setting it to length here. Yeah, that makes sense. Okay, and now R is the address of the slice, and now if we do this, we're actually setting the contents of the slice to whatever this is. Yeah, that makes sense. Right, so what is happening here? What was this? +2, stack frame +2. Oh, we're pushing, it's like pushing, right. So this is, right, because we're pushing. Yeah, okay, well this is the same as saying segment results. Yeah, actually it's this. So results is gonna be the address, right? Or is it the content? I think it's the content. Yeah, this is the location, right? Yeah. We're saying that result location is stored in here. Yeah. Yo, borrow checker. Yeah, maybe show up soon here. We'll see. Okay. Right, and same thing here. This is, I mean, this is kind of like a local ref, you could say. So R, right. So we're checking if the location of the result currently is R. That means R is now used as, you know, as a way to get the locations of the results of the compilation results. So then we're saying that, okay, well then we added some instructions. So we're then pushing that, we're storing the R value in this ref, and then using this. So this would make R usable over here, because we need to set R to be, well, what does this mean? This is just gonna be the string literal. Yeah. So this is saying that R is slice address again. And here we're saying R +1. So R is now pointing to the address here, and we're adding 1 and then dereferencing that, setting that to result. Yes, that makes sense. So this is like saying, you know, slice address +1 dereference is equal to the result. Yeah, and this is setting the address equals to result. Okay. and the result was stored here, or it's just in result itself as a kind of like a so if it's stored in R, that means it's kind of like a runtime value. If it's stored in something else, it kind of means it's something else. Okay. And then here we're sending that, yes, +1. So this would be the address of slice. Address +1 is equal to the result, yes. And then we're popping string literal. Wait. No. What are we popping here? We're pushing that, allocating. Right, pushing the length, and then this should all be self-contained, and then we pop, so this would pop the length, and then we're pushing this. Which is like string literal, the pointer. But why would we pop here again? What's the pop doing here? Because this pushes once, and then we're pushing twice, and then this should be self-contained here. There's no like, yeah, this is all restoring the balance, and then we pop. So this pops the length. Why would we need to do that? Because that will kind of destroy this thing here. Okay, let's remove this pop. I'm not sure why I added the pop there. We need to, although we need to pop over here, so here we need to kind of restore. Well, we're restoring the frame at some point, so I'm just gonna say like pop frame or something. Yeah. Okay. And we can use this as a kind of like a reference here. All right. Now, we have a bunch of places we need to fix, basically. And I think that if we just initialize, we're gonna say dereference is probably false. And then we'll have like init dereference. Set it to true, something like this. I don't know. We could also just add like an options thing. Okay, let's do this. Options. Alright. And of course we get like a million errors because we did not have this before, so right. Yeah, we have to go through everything here. So alloc data, we are getting a pointer to a read-only data section. And add slice is like where it's kind of used. So I think, yeah, I think this is just gonna be a pointer. Another dereference. Push frame. Right, so here we're setting stack frame. This is not going to be dereferenced because we want to set this. Wait, it's over here. Yeah, because we want to set the stack frame register itself, not the contents of where it points to. Okay. I mean, probably most of these are gonna be that, but we have to go through each one to see. So pop the frame is setting stack frame to, yeah, this is gonna be the same thing. Setting stack frame to the previous stack frame, yes. And then we're setting the stack counter, or we're decreasing stack counter by 1. No, this is a dereference. Okay, well, whatever. It's the same thing. Yeah, I think all of these are the same. Oops. What's this new ref? Right. You are. Well, this kind of depends, I guess. We'll just say we'll just get the pointer. It's kind of weird that that we return a location here because it's not like it's always going to be a ref. So it makes more sense if we just return a ref here. But whatever. I think what we'll do, I want to have maybe we'll no, I'll wait with that. I was thinking of adding like a convenience function for dereferencing a location, but we'll see if the need arises. We can do that. Okay, so pop. We're popping. We're pop, and then that. Yeah, the pop instruction. Right. So that should store the thing in the register. And then we get like a location that is supposed to refer to the value that the pop used, but it could also very well just be the address. No. Could it? No, wait, it's because R is not gonna be. Okay, this is where it kind of gets weird, because the register, you're not able to kind of say, hey, I want the address of the register. There's no such thing. Okay, I'm just gonna say this, and yeah, it's just gonna return the location of the register. That should be fine. Well, okay, what we do have though is like a reference to the register, so that is kind of like the address of the register. But it's like if you dereference it, should you go to the content of the register? Yeah, I mean, I guess you would. No, I don't know. Well, we'll see what let's see what happens here. Same thing here. Same thing here, I guess. Whoops. Register is waitable. Right, this kind of, okay, so this takes a value and determines if it's waitable or not. Well, kind of. It's kind of weird because it's not always the case. And now you need something like, you want to have if it's dereferenced or not. So in the case of a register, I'm just going to do this. In the case of this, then we are going. Well, then we have like an address, I think, in here. So I think here we just set the reference to true. Dereference. No. Dereference. Such a weird name. Or a word. Expected 2 arguments, found 1. Yes. So you are on the stack. So if we don't dereference, we just get the pointer. So I think this one does dereference. To get the value. What, is that it? Okay. Okay. Map address. Well, that's always going to return like a pointer. So that here we don't dereference. I guess no, yeah. Oh, that's fine. Map of function expected 2 arguments from 1. What? Oh. Right, if you have a ref with mod, that would do that. Yes, that makes sense. But that means that... Okay, so if you set a ref and we don't have the mod, I mean, I guess this would just be an empty one, or yeah. Okay. Well, there's gonna be a whole bunch of tough stuff we need to do. Just not just these compiler fixes, errors fixes. I don't think. Okay. So where are we now? We are in resolve value. These functions are also kind of weird, like kind of like very rudimentary dereferencing stuff happening here as well. Like, I'm not even sure what the purpose of these functions are, to be honest. Like, it's like if you want to set, it's like, okay, we get a value. What if that value? So this is kind of weird because we shouldn't really use a function called this. Because the thing is, like, the value to get, like, if it's an address, it's just the address, it's just a pointer, right? So the idea of this was that, okay, well, if we got an address, then we need to dereference it. Okay, but the thing is, that should be part of the instruction. Like, the instructions should determine if we want to dereference something or not. So I need to figure out what so the purpose of this is kind of like, if we have a normal value, we just return the normal value. If we have an address, we're dereferencing it. So that means that whatever we put in here is like, well, the action is not to always dereference. The action like depends on the value itself. So that is where it's kind of weird. Because we should always know if we're supposed to dereference or not, and if we're supposed to dereference and we get back like a normal undereferenceable value, then there's something strange going. Then there's like a bug. Yo Piano, welcome back. Hope start becoming a bug bounty hunter. A bug bounty hunter. A bug bounty hunter. Cool. I mean, yeah, I've heard of those for what is it? Those kind of hacker. The hacking community has that. And I think partly because of the nature of like software development, like companies, of course, don't want to expose their code to anyone to be able to like solve their bugs. But if you have like their program, of course you can disassemble it and try to hack it, and if you succeed, then then you can submit that. Yeah. Yeah. Awesome. I wonder how many bugs you have to solve in order to kind of, have that as a full-time job. So I think what we'll do is we'll call this dereference value, and if we get something like this, it's actually going to be like an error. Now the weird thing here is that values themselves can be like a dereference type, but I think we'll just remove that because that only makes sense in like if you have an instruction where you could dereference something to do some specific thing with that reference. So I'm not sure if this makes any sense, to be fair, to have this. So I'll probably remove this, but I will keep it for now, and just so we can fix this, the things happening here first. And same thing here, like resolve location. Well, actually this is kind of different because this location is kind of like coming from the compiler. So it's kind of like, or not the compiler. Well, it's coming from, well, it is coming from the compiler because but it's part of like the instruction. It's not like fully realized, I guess you could say, into an address yet. So you can get this location, and it's like resolving the location does make sense because that means that we're kind of looking into the location to get the value where this location is. And now here, all of these should probably work as they are. However, there's something down here. Let's see. Yeah, I think result register. So this is a value. So what the thing that we need to do is we want to resolve, or we want to dereference the value in R. That's what we are trying to do. And also this location could have its own modifier, which means it's like adding or subtracting to it. So we need to take that into account as well. And that's what kind of what we are doing here as well. We're applying the mod of this location and creating a new thing here as well. I want to make programs for this area. There are some websites allowing companies say things are fine for the piece of my site, and penalties must be like $50 to $100,000. Oh, damn. I hope I earn something. Yeah. I mean, you'll earn and learn and earn. At least. Well, at least you'll learn, I should say. Yeah. Okay. So getting that will. Well, I mean, technically, you don't. Maybe this also depends. Like, if you want to dereference or not. Like, we might just want to get the address as well. Like, we might not really want to get the value at the location. We might want to get. So actually, I mean, if the deref option is on, we get the value. If it's off, we get the address. That makes sense. So for example, the ref is actually going to be Well, it's gonna depend if the dereference option is on or not. So I think what we'll do is we'll say resolve location. So we'll do like resolve location. I was thinking making two functions that does like one does the dereferencing and one just maps like the address. Because yeah, and then this would be like dereference location, and then we'll have one for like map location, or location to address or something. Okay, and then here is like if location options dereference return dereference location, else return location to address. Okay, so now we just need to implement these. So here it's just gonna be ref. I mean, this is just gonna be like location to address, I think. And you're gonna support data stack heap ref. Well, ref is actually, it should be supported if we can get the stack frame here. Well, we don't get the actual address. Well, actually, we could get the actual address. I'm gonna say to address with context stack frame so now it's like, okay, well, it's just, if it's a ref, we can say we'll return ref plus stack frame. Else, I'm gonna do this. Wait, what the hell? Oh, that was the abs. Okay, yeah. Okay. Learn and earn. Yeah, and I mean, we could just do that. Okay. Dereference value, resolve location, dereference location, right. Yeah, so the ref, we get the ref pointer, Yeah, that gets us the value. Heap. Yeah, so all of these should be fine. Stack frame. Stack counter. Yeah, these are pointers, so that's fine. This one is like looking at the value of the register. And if the value is an address, we can just return it directly. If it's a register, which kind of means it's like a reference to a register. It's kind of weird. Like we can store a value that is like a reference to the register with a mod. So it's kind of like having a little instruction embedded in the value itself. Because I think that's not really a valid value, like, because it should be resolved if it's used. Like it's fine if it's part of an instruction, like the set instruction, for example, location. This is the destination, you could say, and then this is the source. So we're kind of saying that we're setting the location to this value. But in order to kind of say that, okay, well, what if we want to set the register R to register stack frame, for example, then we need to be able to represent register references in the values. But that doesn't really make any sense, because values should probably not be references like that. They should only be like resolved values, I think. Like, or addresses. They could be addresses, but not references to registers. I don't know, something just feels wrong about that. So what I think what we could do is change this type here to be something like, you know, set destination or something. Because, well, or not destination, source, because it could be either like a constant value. It could be a literal value, or it could be an address. It could be, you know, a reference to a register. But then when you actually have a reference to a register, it doesn't make sense for that reference to be like passed around as an actual like real value. Like there's no value in, let's say, assembly code that you can use to represent a reference to a register, unless you kind of hard code that into the instructions to kind of interpret it as that. But there's no like thing like that. And it complicates, the issue is that it complicates things over here, because it really should be simple. It should really just be simple. Like if we remove these two types of values, we only end up with, we don't really need to do anything. We can just do this in the end. So I think that's what we want to do, because this doesn't really make sense. I don't think even this scenario will happen here. But I think what we'll do is I will go through and make these changes first, and then we'll go back and fix these things to kind of isolate those issues, because right now I just want to get this working first, and then we'll kind of go through and fix those things. Okay, so what is this? This is dereference value. Yes. and then we have this dereference. I'm just gonna do this. Okay, I'm gonna. Okay, let's just comment it out. Actually, let's do that. Fine, because now we're getting like these errors here, and then that's okay. But U is because of what? Unsupported address type. But isn't that part of this? Yes. Oh, it's a U size. Okay, you get a U size, right? Oh yeah, that's right. So we actually have to do like from address here, and then try. There we go. Okay. Expected type. That found optional. Right. So let's just accept an optional here, I guess. And then there is like location mod. I'm just gonna do this. Mod is mod or else empty. Yeah. Don't feel them empty. It's weird, the LSP does pick up on what I mean here. Is it because it's like... No, now it works, okay. What was the error here? Is it because it's like optional? I don't know. Okay, well that works. Great. No error named, unsupported, resolved value type. Wait. Yeah, okay. Let's also do, whoops, did I say? Let's also do this. There we go. So it's like if it's stack, we dereference this address here, yeah. Okay. Well, that should be the same as this. Like, we don't need to have the heap here as well. This kind of handles that as well. Because if it's a heap, or maybe not. Yeah, if it's a heap, we get it. So we actually don't need this here. And I don't think we need this either then. Oh, this doesn't apply the mod. No, but we get the mod applied before, right? Okay. Whatever. Okay. Great. Okay, we don't have any compiler errors left. Oh, I see. Yeah, it's yeah. Everyone seems to have like different names in Discord and everywhere else. I usually have the same name everywhere. I don't see you now, though. I don't see you online here. Yeah, anonymous. All right. Okay. So I mean, yeah. If we go to like basic, how many? Oops. Yeah, of course that's gonna be an error. So let's start fixing these things. I wish it showed me more. Unsupported reference type. So what we're gonna do, I'm just gonna go into value and I'm just gonna delete. I'm just gonna do this and the register as well. Yeah, but that does mean that we need to fix a bunch of stuff. There's gonna be a whole bunch of issues here, yeah. So what we need to do is we need to go into instructions, and for example here, we're gonna have to say that, well, this is gonna be like a source, value source maybe. So I'm gonna make a new thing called a value source. And it's gonna be either like a register, which is, I think, where is that actually? Is it location? No. Is it all in here? Yeah. It's not public. Yes, it is. Okay. Is it register or just register mod? I guess we could have mod as well. Now actually no, we could just have location here. Yeah, we could just say that, okay, it's either going to be a location or, because that has dereferencing and all built in, registers and everything built in. Or it's going to be just a value. And it's a union, you know. And yeah, so now we go back to here. So now so I'm gonna call this source instead, and this I'm gonna call destination. But the destination is just a location. Yeah, that makes sense. The source though needs to be a value source. Okay. There we go. I guess I'll add a format function here. We'll just do inline else print f for format. There we go. Okay. Right. So we have that. Now we need to go to. I'm gonna go this way, the evaluator first, and then we're gonna try and fix this. So set ref. So what we need to do is we need to kind of evaluate this value source. Hello, Baby Yoda. Welcome back. How you doing? Into a value, and it's like if it's a location, we have to dereference the location, I guess. Well, I mean, yeah, no, yeah. Then we resolve the location. If it's a value, we just use the value directly. So let's go to resolve location and actually make another function called resolve value source, and that is gonna be this, give us a value and so on. Value source is something that we need to get there. Okay. Now. Oh, great. I'm doing great. It's nice to get back into this a little bit. There's a lot of things going on work right now, but I have a couple of hours here that I can spare. Alright. Now, got a few days of work, I guess. I'm working on some projects. Okay, nice. It's nice when you get some time to do things that you want to do. What kind of projects are you thinking of? Let's see. Alright, so we just switch on the source, and if it's a location, we just, let's return this. We just say resolve location. If it's a value, it's just going to be the value itself, I think. We're just going to return the value as is. I mean, technically, I guess technically, like if the value is an address, you could technically want to dereference that. But then, wouldn't that just be a location? No, it wasn't. It's like a runtime value, maybe, I guess. But how would that be possible, though? Because value, in this sense, value is probably just going to be a literal value. Yeah, otherwise it's just going to be, it's actually going to be a location, I think. So I don't think we actually need to kind of worry about the address type value here. I guess we'll find out if that becomes an issue. Okay. So we're gonna get the source is gonna be resolve value source. There we go. Same thing here. Resolve value source. Oh, by the way, is this correct size here? I accidentally resized it. There we go. I'm making computer vision AI training tools, and I write Python, which I hate. Where I'm slow in Python and hate duck typing. Right. Yeah. Duct typing, is that what you call like when you have like kind of like TypeScript, or what do you mean? Because I'm not sure if does Python actually report like if you have conflicting types. Because I know Python is dynamic, but you can assign types to things. Hints, okay. But it's like if you assign something to a string, let's say, and you, or I mean, yeah, you annotate. I think the term is with a string type to a variable, and then you set it to an integer. Will it be an error? I mean, I guess it would be a warning at least. I hope. It doesn't really enforce them strictly. Okay. It errors. Okay. So it's like if you have an inferred type, that means that is, well, it's not inferred. Well, I guess then it's not strict. What are you making? Register system? I'm making. Well, yeah. I'm touching on that. I'm kind of making like the virtual machine and the instructions, like how they kind of interpret addresses, like pointers. You could say like pointers and dereferencing in the IR language. If you want strict checks, you have to use hints everywhere. But oh, I see. Because otherwise, you have to use some types. Okay. Ah, I see. But that is actually how TypeScript works as well. Although there you can also use. Well, sometimes. Well, you can use inference. Well, in TypeScript it's also interesting because TypeScript is also like that. However, it does infer the type, and if you have conflicting types, that will be an error. So in that sense, I guess it's more strict. But you also have to, like, if you say that something is a string and you want it to be optional as well, then you have to have that in the type. But I think that's a good thing. I mean, for me personally, because it's like then you have the option of setting something to say that, hey, this can't actually be none. So I think that's good. But of course, then it's annoying if you have to type that whole thing out. Like in Zig it's nice because you just put the question mark there, so that would be a nice thing. Having more issue with ID function that gives you the unique ID of an object. Okay. When I pass this ID to a method, it's getting truncated to 32 bits or something like that. Not sure, even though the return is int. So okay, so is the ID is like 64 bits then, or this is the actual ID is the key? Okay. I mean, is it because the function that takes the ID expects another type, or changes when it gets passed to the method? So what is the type? It expects int, but okay, but what is an int in Python? See, this is the problem with those like types. Is like you don't know like how large they are. Like you don't know if int is a 32-bit or 64-bit. So I mean, okay, then you could guess that okay, it's probably a 32-bit then if it truncates it. So you should take maybe can you have a long, or can you specify that? If you change int to a long, I'm not sure, I don't know what types there are in Python though, but is this a notation? How is the notation? Oh, it's def. Right. And how is this? How do you get the ID? Is it just do you have to have something here, or okay. There we go. It's different. So first I'm using the actual ID, and then I added 5. Okay. That's right. Yeah. Okay. Thank you. But it's the same though. But does it? What is an int though? Okay, so 32-bit is like 2 to the power of 32. So that's 4.3 billion, and this is way more than that. So it has to be 64. I mean, are you perchance running on a 32-bit system? Yeah, there might be other things happening. You should inspect the function maybe. Like, have you logged, tried to log the things? Okay. I'm just gonna refill my coffee, BRB. Basically, running a training queue for models on a separate thread, and I extract the percentages from. Alright. Well, I'm not sure what's going on. Right. Dereference value. Yeah, it should only work for address, right? Data register ref. But ref should be possible. No, because it's like it's always gonna be the stack. Yeah, this never gets us a ref. It only gets the stack, read-only data, or the heap. Yeah, this doesn't happen. So, wait, what about data though? How is that? Well, that should be possible. Wait, what the hell? Yeah. Okay. Oh, I see. Data. Right. Data get. There we go. Oh, we don't know the length though. But wait, but then we just get a byte back. Yeah. I don't know, it sounds strange. Okay, yeah, sure, whatever. Let's do this. I should really just forget about having the register should not be a value. The heap and the stack should not be a list of values. They should be like just a byte, a list of bytes, because then it gets very close to like assembly code, and also, you know, you can do whatever. Everything will just align at that point. Yeah, okay, well, whatever. We'll probably maybe do that at some point. Expected this, found that. Right, so here we're setting heap. But again, we're not taking into account dereferencing into account, and we're not taking the mod into account here either. And not here either, so okay. Yeah, these two doesn't work. Okay, and then ref is just, we have the source, we get the source, we set the ref, but it could also be modified though. That's the thing. So actually, let's add a mod. There we go. And for this, it's like stack address is going to be stack plus, or no, it's going to be apply mod onto the stack, and that's the address we will use. But then we also have dereference, so that's the thing. Like if we have dereference, we have to go one step further as well. So what I will do is I will say destination is going to be the address of this. Okay, and then here is like the source is this. But if it's a dereference, so I think this part is kind of, this part is going to be kind of the same here for all of these. But then how we get the destination is going to be different. But I'm just going to lay this out for now. So if we want to dereference, that means we don't want to modify this destination. We want to go into the address that this destination points to and set that. So presumably we have an address at this destination. So this destination has an address. So I think so we have dereference location and value. However, the thing is, like, we want to do dereference value. However, we also want to get like the pointer to the value so we can change it as well. But if we don't dereference, then we just do this. Yeah, so this should get us the pointer to the value. Although, however, yeah, this shouldn't be, this should not be, this should be like an error, I think. Yeah. All right. Okay. Where were I set? Do we have anything left here? No. So basically, this is going to be kind of like the general the generic thing here. First, we get some kind of location or address that we want to modify. We get the actual value where that address resides, or we get the residing value at the address, and then we also have what we should set it to. Okay, we need to do more things here, but if we dereference, we want to now change. I guess we change the destination actually to be this instead, and then in the end we will set that destination to be the source. Yeah, this makes sense, right? If we want to do a dereference action, kind of, that's what we're saying here. We're doing that, and then we set that to the source. Okay. Yo, Penguin. Borrow Checker was in here missing you before. Welcome back. Yeah, so this will be the generic structure here. So I think that what we can do is kind of break out the part where we get the destination, I think. And what we have is a location, right? So let's say, what is resolve location, let's say. Okay, so what if this returned a pointer instead? Can it do that? What about the address? That doesn't make sense. I mean, yeah. I guess in the case of dereferencing location, we could get this maybe. We'll see. So this gets the pointer, so we just need to not dereference here. Here, these two. Wait, this doesn't dereference, I don't think. No, this needs to be dereferenced. Yeah, we need to do dereference value here. And the value is like this address here. Yeah. There we go. And since you do return a pointer, so that's good. And same thing here, dereference value. Alright. And it's like, okay, dereferencing the register is going to get the value inside. I think we need to dereference the register itself as well. So we're gonna say dereference value here as well. Yeah, I mean, I don't know, man. I would just try to add as many debug logs as I could see, or just, can you run a debugger to just step through and then be very meticulous to, and have like a watcher on the value, or just check every time you step or something to see where the change happens. Right, so that dereferences the register. Yeah. Okay. And otherwise we just do that. Okay, cool. So now we actually have a pointer here as well. So what we can do in the set instruction is we can say the destination is going to be, well, it's going to be like How do we do like in the case of it? Being so if no set destination options dereference. If the reference is true, we can simply say try self dereference location set destination. Otherwise, what do we do actually? Because otherwise we kind of have to do these things, and I don't think we kind of we don't have a thing where this is happening right now. Well, I mean, no. Yeah, I mean, I guess it's this one. We can make it into an address. Wait, hang on. So dereference location. The point of this function is to get a location which could be like, let's say it's the stack frame. And it would get the value at the stack. Yes. Okay. So that's what we're doing here, yeah. And the same thing here, yes. Yeah, so that's correct. But then, okay, and then it goes in here and we get the address, we get the stack. Right. So dereference value takes an address and gets us the pointer to that. That is correct. But okay, but what if we want to set a register? That's different, right? So we kind of, I think we do need to have the register as a separate thing, but then the rest could basically be consolidated into the same thing. So kind of like ref, stack, and heap, they could be the same, doing the same thing. You know what? Let's forget about this generic thing. Let's just do it case by case, and we'll see how we can do it there. So the ref here is the same thing. Well, we kind of already have the thing doing the thing here, except we don't take into account the dereference here. So if we want to dereference, we actually want to get this pointer instead. So actually, I'm gonna do this is gonna be thread get ref pointer ref and then the mod. Okay, and then we don't actually set it like this, and we get the source and we say the same thing. If this is true, we do that, and then we set this to the source. Oh, it's because of a C library that truncates it. Oh. PyQt. Sounds like a lot of things going on there. Yeah. Okay, and then the heap should be the same thing. So we get the pointer. It's the only decent UI library for Python. Okay. Interesting. What about a web-based solution? Running like a Python server. Okay, so the heap, get the pointer heap. So this is just a number, right? So what we do is we do basically the same thing here. Oops. So we get the address. We get the destination equals thread shared heap get pointer to address. Now this is heap instead. And then we also have these things. And we have source. Yeah, see what I mean? These things are the same, like this part is the same. The only thing that's different is this and whatever comes before it. So what I was trying to get was just a pointer to the value, and then the rest of this is always going to be the same. And actually, whatever happens here, the source will always be the same. So I'm gonna just do that here, so that we don't need to do that. And also all references to the source will be done like that. And here's also interesting, because if we set the register to this, then we just set it. However, we can also refer to the register as a kind of like what I was trying to do here, like a dereference. So we should have a case for that. So I'm gonna say if we dereference, then we have a different thing. So actually, same thing here. Destination equals thread private result register. If we have a dereference, we just do that. And here's like, okay, we want to set the stack frame. It could be the same thing here, so we need to do this. What's happening here? stack frame equals destination. This doesn't make sense. This is the destination. If we have a mod to the destination, that means we need to sort out the address here. So actually, like if this is true, we want to do something. If it's not true, we simply want to set the stack frame to be the source.uinteger. So this has to be a uinteger at this point. I guess it could be an address as well. Now it has to be an address, right? Yeah, we're gonna have to check how the implementation is here. That would be slower. It would be fun. My friend told me Django is really slow. Maybe something like web view. Interesting. I mean, of course, it's probably slower than just native, you know, renderer or something, but it's nice to work with, you know, like I mean, it's gonna be as slow as a web page. Or is like the server slow, or what's web view 2? Yeah, I don't know. I don't know too much about Python web stuff, to be honest. I just know I did see one like presentation where they had used, I think it was Django and HTMX to build a really nice web application. But yeah, it's I don't know. I'm kind of used to like React and all that usual shenanigans. Thread private stack frame. Yeah, this doesn't make sense at all. So that just sets it directly, right? Yeah. And it's like if you, let's say you have a stack frame not dereferenced, then it doesn't then it doesn't make sense to have a mod at that point. Unless because we want to have a way to set the stack frame register itself. Yeah. Okay, and then if we want to dereference, that means that we want to reach into the stack itself. So now we're kind of working like exactly like the stack thing. So this is gonna be just like a normal, like this, and then destination is gonna be whatever's happening in here. So basically all the rest of this. So we get the stack, we get the address that's on the stack. We do the same thing now as we do with the stack here. And then the same thing with the stack counter as well. So that is, however, the stack counter, okay, yeah, it has a different handler for setting the actual stack counter register, but how is this? This has to be a try here. Okay. Oops. Oh, because it was like an expression before, and then we already tried it up there. Okay. So this would happen in the else there, and then of course this, it only makes sense if this is an actual, like, if this is an address. We'll have to change that later. And then yeah, and then this is basically the same, except this is now the stack items length instead. Okay, so basically if we dereference, no, now the registers are kind of aligned here as well. The only place where it's kind of we have special treatment is only gonna be when we set the actual registers themselves to something. Okay. It's more comfortable to mouse when you can use front-end frame with server UI. Yeah. In Qt they have QSS. Oh, like CSS for Qt or what? But it's limited on what you can do. Okay. Yeah. When I first started to, I wanted to create like an editor for my game. I started out trying to make some kind of web view for Zig, for a Zig backend, and there are some of those that I've seen. Well, this was like 1.5 years ago now, almost. Not really, but more than 1 year ago. And yeah, I didn't get far with that. So I went over to using imgui at the end. But I mean, yeah, imgui has nothing on Qt, I would assume. But yeah, Qt has video player, icon loading built in. Okay, rendering is native. Honestly, I don't like how blunt it is. Yeah, it feels like I mean, it has existed for a long time, and there's probably a huge amount of features, but it's like, yeah, as you say, it feels really bloated. It's like, also it's like when you run a Qt app, it just feels, I don't know, it just feels like unstable or something. I don't know, it just has this feeling of I don't know. I don't want to bash on it, but this was years ago. Like, I haven't opened a Qt application in like, I don't know how long, because I don't use Linux nowadays. I use Windows, so maybe it has to do with something else, but yeah. But there's like Qt for Windows as well. Like, that's the whole point as well, to be cross-platform as well. But yeah, it's quite professional, but the issue is like 3 million lines of code. Right. Wow. Okay. It's also, you have to learn how it's done in that library as well. Friends using it for his game editor. Okay, cool. Yeah, sorry about Nightbot there. It's like the default settings. GameKit. I didn't know that Qt had. Well, so Qt is C, but then Python has bindings. Cool. Working on it for 10 years. Wow. Holy crap. Python has a version called PySide as well, as used commercially for free. Huh. Cool. Awesome. All right. What's happening here? Okay, I need to think about this. So push is now doing stuff as well. So I think we'll do the same thing with push actually. I think we'll push values. Actually, let's do like a value source instead. Okay. Push will append, and then we don't do this. We do resolve value source. There we go. Okay. Oh yeah, try, right. Okay, now we get a whole bunch of other things. You get a pointer, so I mean, I guess we just do this then. Can you do this, or do you have to? You have to do this, right? Member function expected 3 arguments found 2. Pipe, right. Okay, yeah. So pipe still uses like a ref or a result, which we all assume to be a ref. Set ref. I mean, I guess we will do this. Well, actually, it's a location. No, yeah, we assume that it's a ref, right? Yeah, yeah. The only reason I'm using it is that I understand it, to be honest. Like, okay, Django HTML could work, but then you have to use a tool through a browser, which is just a little weird. A web view electron is not something I know. Yeah, I mean, electron is not that difficult though. It's like, well, it does require you to learn a little bit, but it's like as soon as you have like the main kind of thing set up working, then it's not that bad. But then it's like, well, yeah, then you have to like, yeah, I think if you go with a web, like just a web browser, or I mean a web an HTML server, then I mean, yeah, the upside is you can use whatever to do the front end, and then the back end is like you can also do whatever. You just need a server that receives the things and that receives the commands or whatever. But yeah, it kind of depends maybe then on like what kind of application you're trying to do. So you're supposed to load a video and train from it. And images. So that would be weird sending up by HTTP. Well, it's not that weird because it's kind of made for that. I mean, well, the thing is, you don't really need to send that. Like, if you want it to be displayed, do you want? Okay, that's the first question. Do you need it to be displayed in the browser? Because if you don't, then it's just a matter of like having the server actually load the files from disk or whatever you're getting it from. I think you might even be able to kind of use the like pass a URL to your local file system. But yeah, if it complicates things too much, then it's probably not. I mean, if you think it's like bad for your bad for your endeavor, there, it's probably not worth it. I don't know. I just suggested it because it would be a good choice for me personally, but then I'm used to, or that's where I'm more used to like web. I've never done like Qt. Like ImGui is also like, I guess it works, but it's also like it's very like basic, or like it doesn't really have a lot of features. It just has like a bunch of basic stuff. But yeah. Yeah. Let's see. Arithmetic. You are okay. So the thing is here, like dereferencing. Like we don't need to dereference. Like this is the thing. Like this is a like A is a value. Now the thing is, this could also. I think this is like this should also be like a value source. I think. Yeah. So let's do resolve value source instead. There we go. There's our values. Awesome. Same thing here. Oh, that's the same thing. Okay. And here as well. Cool. Oh yeah, set location. Only works for refs. Okay, fine. For now. And push takes value source now instead. Qt's video player, all built in other stuff. Just giving Qt a chance. Guess I've seen you strip it down. Worked with it before, but only for a very basic 60 camera app. This is the first time I'm trying to do something more serious. Okay. I mean, I would say, like, if you're familiar with it, it's probably a better choice. If you just want to make it work. I think that making like a web-based, I mean, to me, web is, it can do so many things. Like, I think that web is like, it can basically do anything that a native app can do, almost. Like, it's and another benefit is that CSS is like, sure, it's like, it's a pain to work with sometimes, but for most of the time, if you learn it, like, that's the thing. Like, if you're good at it, then it's a good choice, because it can do a lot of things. It's just that if you want to do some, like a program that works with that, you have to kind of, you make the server, and then the server would receive commands from the web view, which then triggers, you know, to run commands, do whatever on the server, like, which would be exactly the same as, you know, a desktop program or whatever. The only difference is that you're detaching the front end and you're receiving commands through like HTTP or something instead. Or you can also, I mean, you can also have like a socket, web socket, that if you want real-time updates from the server as well. I just think that's an interesting thing, like making programs using like a web view instead. Now, sure, it's gonna be, it's more like you distance yourself from the functionality, but it's an interesting thing. Yeah. So how large is your project right now? You could run this tool on a server and access a panel. Yeah, exactly. You can also have it like as a service. Like you can host that somewhere and then have, you know, and then connect to it anywhere and have the data be stored on the server as well. All right. Set location. Where is the? This is weird. Like this function. Okay, it's used only for these binary things. Like really, what we should get is, because resolve location gives us. Does that give us a pointer? I forget. No. It's because this gives us an address. Right? It either gives us this or that. Okay, well, I'm gonna leave that alone for now. We might change that later, need to change that later if we want to support, because now we can't support like adding, well, we can add whatever to whatever, but we can't store it in anything other than a ref right now. Okay, well, anyway, else prong required when switching on that. Okay, let's see what we're trying to do here. So we have a value, we resolve it. Yeah, this is the thing. Like, we don't actually want to do that. Just sneezed. Because the value here, like, where are we calling this from? We're calling it from here, which is the execution thing. Okay. Is it called from anywhere else? I don't think so, no. Okay. So it's basically only used for turning like the arguments that are pushed to the stack into strings. And here's where we also need to figure out how to implement the new thing that we did with string interpolation expressions. I'm making you think to do it in Django, yeah? Would be cool to have as like a hosted service or something. Yeah, that's the huge benefit, to have it as a web-based thing. Would be interesting to have for people who have dedicated ML machines. Maybe I'll just get it working for executor for now. Migrate to that. Yeah, I don't want to send you off on a quest, never-ending quest there, but you could build a prototype maybe in Qt. I don't know. Okay. Anyway, so yeah. So what is the value that we send in here? This value, I mean, we have to go to the compiler at that point to get that. So I think for now, we're just gonna say that we don't dereference the value, we just use it directly. Okay. There we go. And then we can figure it out. So now I think the evaluator is kind of done. So now we have a bunch of stuff in the compiler we need to fix. Hello, Polaris. Thank you. Have a nice day. Yourself. No field name. Right. So, yeah, we don't have this dereference anymore. What we do have. So this, all right, so this is the result type, I think, yeah. So from location. Now, where do we actually use this? Function call. Gives us a handle. Yeah, so maybe it doesn't make sense to have this just as a value right now, since values are supposed, like before we could have values as anything, basically like an address or a register reference as well. Now we can't have that, so we might do a value source instead. Is since that can be either location or value. That does make sense. But then that requires us to now change a lot of places. And I'll rename you to source. And location. I mean, we don't really need to do anything special here. We just say location is location. Okay. So now we need to go through and fix a whole bunch of stuff. Push frame. Right, so what are we doing here? We are pushing this thing here. I mean, we have push already. We could just reuse push. And then the thing that we want to push, because push does the same thing. Like it. Oh, I see. It doesn't do this though. Oh, but we do have this convenience function here that I'm not using here, so. Okay. So we are pushing a value source. Now let's add some convenience functions here. Value. All right. So this will be from location in its absolute register is stack frame option. So what are we doing here? We are pushing. What are we pushing? We're pushing the contents of this register to, yeah, that's what we're pushing to the stack. Which is basically we say we're saving the previous stack frame. What are you working on? I'm working on the intermediate representation language of my scripting language right now. Right now, I'm kind of reworking how we talk about addresses like pointers and dereferencing stuff and all that. Never written Zig in my life and have any experience with it, so what the hell is even an inline else? An inline else means that, well, let me show you here. So let's say you have a type. I'm just gonna call this like animals, which is a tag union, and we'll have like a cat that has, let's say it has like a name, and a dog has a name. Let's say they all have the same type here. Okay. Now let's say we create an animal here. Let's call this animal. Okay, I'm too pedantic right now. Let's do like animal, and this is a cat that's called, I don't know, Oscar. Okay, and then we'll switch on the animal. So the switch now is like, okay, let's just go through what a normal switch can do. So basically you can type out, you know, cat and dog like this. So this would indicate, in the case of that animal is a cat, we will, let's log out animal is a cat, for example, named, and then we can get the name here as well. Actually, let's call this name. Okay, so what's happening here is that we have a case for cat. Okay, so if animal is a cat, we get into this branch here. Should be a comma here. And what this is called a capture, which means that we're capturing the value of this cat. So it just means that we're binding this identifier to whatever value is in cat here. So this is the same, this has the same type as this here. So it's basically this value over here. Okay, that's what we're binding name to. We're binding it to this. And then we're logging out this thing here. Okay, and then in case of a dog, we also get a name because it has the same thing there. Animal is a dog named this name. Where's the issue here? Oh yeah, we don't have standard, so we have to import that. So there we go. So now if we run this, run, we get, of course, that the animal is a cat named Oscar. Yeah. Okay, so that is like what this normal switch is doing. And now let's try and change this, because these two are basically the same thing. So we could utilize that fact. So let's actually, I'm gonna comment that out, do another switch on animal, and we'll do an inline else, and animal is a named, and actually we do get another thing here. Okay, so what's going on here? Well, name is, well, we don't actually get like LSP here. I'm just gonna run this to see if this still works. No, there's an issue. Oh, I see. There we go. And now we don't get that either. But if we run this, we get the same result. Animals, a cat named Oscar. So what's happening here is that name is referring to whatever value is in like this. Each tag has associated value type here. So whatever value is in here is gonna be the name. And T. So this is how the switch inline else work. You get two values that you get in the capture. The first value is always going to be the value of the tagged union, and the second value in the capture, the T here, is always going to be the tag, which corresponds to cat or dog here in this case. And then we can format it here using the T formatter to get that tag out. So let's say we add another animal. Animal 2 is a dog named, I don't know, Rosa. I don't have a good name. But actually, let's make this a function instead. Let's do like print animal. And we get an animal. And we'll put this in here. And there we go. Now we can say print animal 1, or yeah, animal and animal 2. And yeah, this can't be an error, so let's just remove that animal type, error type. So now you can see that we get these both cases here: cat named Oscar, dog named Rosa. So the inline else, what it's actually doing is kind of expanding to this. So I'm gonna explain here in a second. I'm gonna try this as well. I think you can do this. Yeah, you can also capture the tag here. So then you can also, you don't have to like hard code this. You can actually use the tag like this to run this. So now, or can you actually? Non-inline. Okay, so you can only do it on an inline prompt. But basically, what this is gonna do is it's gonna expand. It's kind of like code generation. It's gonna expand this switch to be this. So that's what it's doing. So based on the tag of this animal, you're going into separate cases. And if you have an inline else, this code is like expanded into this. So it's the instructions that are generated is going to be this switch. So yeah, so this is kind of what the result of this will be. And then if you add another one like a snake, we get animal 3, which is a snake named, I don't know, Jonas. Then you get yeah, and then we print it. Then we get this, right? So it's a way to kind of let's say you have this pattern. You don't need to implement all of the different cases manually. You can do it through inline else. But then of course, if you have, let's say we have like an elephant, and this now is something else. Let's say this is a size instead, a U size. It's just an unsigned integer, and now this won't work because it's different. So if we do like elephant 4, we're gonna get an error here, because when it comes to over here, and this is not always a string anymore. Now this is like a string or a number basically. So it depends on S, but what you can do is you can say, well, let's make an exception for elephants, because we know that we have this, I don't know, age maybe. And so animal is an elephant. Okay, now it says A here, but whatever. With age, and then we have to format it properly here. So there you go. Now we have a special case for elephant, but the rest keeps like some kind of pattern here that we can that we can use. And if we now run this, we get an error. Oh yeah, the t, we can't use the t, but however, we can use the t of animal itself. Because animal is, you can kind of coerce it into the tag by using the t formatter here. So now we can see that the elephant is an animal, is an elephant with age 5. Did I set it to 5? Yeah. So yeah. So yeah, that's how that works. So it's a pretty nice thing that you can use in Zig, which is kind of like one of the most basic kind of like code generation, I guess you could say, things you can use. There's also inline 4, which could be used to loop through, let's say, a field of struct. So let's say you have another, let's say you have like a car, which is a struct, and then you have, I don't know, model name, number of wheels, and I don't know, doors. Yeah, and then let's say you want to kind of list, like you want to print this out using a special formatting. So, well, normally what you would do is you would actually make a format function in here, which you could do as well. So, but just to illustrate, well, I guess we could do this to illustrate this. So if you have a format function, it's kind of like a special function. It's not really special, but it's like it's used in this by the standard library. If it detects that you have a format function in your struct, it can use that to format this type. So let's say we want to say like writer, and then we have this writer which we can use to print to some destination. So we'll print out car, or in this case we have to do like write all, and then we'll do like 4. So now we'll do inline 4 self, well, standard meta fields of the car. So this means that we're kind of getting like the fields of the car. So we're looping through all of these fields. We have 3 fields here that we're looping through. And we get the field out here. And now we can say that oh, 1 second here. Alright, sorry about that. So then here you can say, well, first we need to get like the field. I want to get the field value. So the value is gonna, then you can use the @field kind of built-in function that you can use on self, and then you provide a field name. So this field name we get from field name. Now this corresponds to model, wheels, or doors. But it's all like compile checked, so you can't supply like a name that doesn't exist. That will be like a comp time error. But now we get some kind of value here, and then we can do print, and we can say, well, depending on like if this, like, yeah, this is a model name, so actually this will be this will have to have like a different format actually, because you have to have like S. So I'm just gonna say if field if we have to compare now. This example went, I thought it was gonna be pretty simple, but it actually was a little bit involved here. But let's say we have the model as the field. We actually we have to use the S formatting. Otherwise, we will format it normally. Okay. So what this is gonna do is it's gonna also expand this, but it's gonna expand it for all the fields. So we will get basically copy this part 3 times, one for each, you know, thing here. But also it's kind of like this if here is also comp time known, because the field name is comp time known, this is comp time known. So actually in the case of model, this will be the only instruction that gets actually like put into the real instructions later. And then for the other two, this will be the real instruction. So actually this will end up being, this whole for expression will end up being first, you know, self.model, and then self wheels, and self.doors. So that this expression will end up being these 3 expressions. However, and you might think that this looks way nicer, but what if you want to add more things? Then you have to add it down here as well. So if you want to add like more things, yeah, you have to do it here. But if you have this generic thing, you can add things without having to like modify this, unless you add something that needs, you know, a separate, another type of formatting thing. But yeah, it's just to show that inline for also works kind of like inline else, in which you're kind of using comp time to generate code. Okay, so what if we use this now? So how do we use this? Well, let's make this car over here. So let's just say that this is, I don't know, my model. Let's just say to not, and let's say we have 4 doors and 5 wheels, just to be special here. Okay, so we have this car. Now how do we print it? Well, we can use the F formatter to print the car now, because so what this does is that it looks into the type of car and it sees that, hey, we got a format function, so we're gonna use that to format the car. Okay, so if we run this now, we should see, well, we're getting some errors. What's the error? Cannot format slides without specifier. Invalid format S for type uses. Okay. Well, this should be comp time here. So there might be that we have to kind of say that this is comp time. Not sure if we have to do that. There we go. Yeah. So in this case, you actually had to add the comp time here to make sure that this is not happening in runtime, it's happening in comp time. So I thought it would automatically do that because field itself should be comp time known. And this is also comp time known. So I thought that equal actually checked that. Like, yeah, but anyway, now you can see that this actually works. We get this car. Oh yeah, I forgot to add. Actually, we could add write a new line here after. There we go. Oh yeah, and what you also can do is you can say, of course, the that's the value. But what if you want to say the name of the field as well? Well, then you can just say field name. Like this, you will print out that. There we go. And now we get the field name as well. So that's a nice way of kind of, we can loop through the fields of things and do things with that. So there's a lot of potential you can do with the comp time stuff. All right, so I went on a bit of a tangent there, but I just wanted to show that as well. So that's the inline else and the inline for, and also the format function I showed a little bit. Okay, cool. All right, back to this mess over here. I'll do a little bit more here. I don't think we'll, because I don't have much time left, but we'll do a little bit here and then I have to call it. I don't think I'll be able to complete all it. Let's try and fix all of these maybe, and then see if anything works at all. Okay, so what's going on here? Right, push frame, that's right. So first we push the stack frame, yes. We also set the stack frame. Now this is a location. Yeah, that should be fine. You know what? Let's add a special case just for registers, because the registers are a little bit special. Because really, they don't really... it doesn't really make sense. Like if you just want the absolute, if you just want to have a refer to the register itself, it doesn't make sense to have a modification. I guess you could dereference though. No, let's forget about the options actually. Yeah, let's just do that. It's a register reference. So now we can say register, whoops, stack frame. Okay. Yeah, running series in Sigma spaces. Yeah, it's actually pretty nice. They did update like the writer interface in the previous version, I think it was, and it's really nice now. Does your IR have infinite registers? No, it doesn't. It actually only has one. It has one like general purpose, I guess you could say, register. Although it's not really general purpose because it's more like used for returning things from other compilation units, I guess you could say. So it's like if you compile something and the resulting thing is the register, that means it's like a runtime value, kind of. If you get anything else, it kind of means it's like a literal hard-coded or read-only value, basically. I'm starting on the Django thing now, to be honest, because the thing gets too complex. Oh, cool. I hope it goes well. I mean, how familiar are you with web dev? Because there's no point in going to that if you have to kind of relearn a whole bunch of stuff, I guess. No field name, register in... oh yeah, so we're setting, what are we doing here? We're setting the stack frame to the current stack counter. Right. Very familiar with this one. Okay, cool. So that would be, so this is a location. No, it's a value. Actually, it's not a value. This should be a source, value source. Okay. And then we can say from location register stacks counter. Okay. Oh, right. Let's do that. Okay. No field name, new integer in boop-a-doop-a-doop-a-doo. Right, so that would be like a value. Switch value source. Right, so now we're kind of looking at the value source. So this could be a location or a value. I guess this would be like only support value at this point. So, man, I wish there was like a fall through, like a, you could fall through over here. I guess. Ah, man. Actually, let's do else null. And then we do like an or else case. We do that. Yeah, from value. Okay, so it could be the register, the R register. Right, or a location. Dereference register. No, so it's only if it's a location that is a register. Okay. There is not a function. Wait, didn't we do this already? No, you're an exit code. What the hell? Oh, I see what the issue is. Okay, so the resulting type here is actually gonna be like this. I think we need to do like as We need to kind of supply the type like this. No, not that part. Actually, it's this part, yeah. There we go. Okay. Expected type value found value source. Yes. But this part we're gonna redo anyway, so I think I'm just gonna do this for now. All right. Hey, cool guy. It's been 2 days. Yeah, I've been busy with work, so sorry about that. I wish I wasn't, but that's how life is. Yeah, I'll be off on Thursday and Friday, so there's not going to be a stream. Probably, maybe tomorrow. Wait, is it Tuesday today? Yes. So tomorrow there might be a tiny stream, and then there's not going to be anything until Monday. All right. Let's see if we can fix this before 1 o'clock my time. It's in 18 minutes. Should be able to do it. No field name slice in enum. Okay, so yeah, because this is now a thing. So compile call, the source does not make sense if it's a location, I don't think. We're just gonna do like value. Yeah, same thing. If it's a location, I don't know if this is gonna be like an error. I'm just gonna do this. Actually, this is like location like this, and then like that. Okay. Yeah, we're narrowing it down. What is the 6 near compiler.zig? What? Oh, this one. It's errors. I'm pretty sure. 1, 2, 3, 4, 5, 6, yeah. Call this source value, or just V. Yep. although not everything, not all logic is in here, and also there's like some logic that maybe should be elsewhere. So only 6 errors. I mean, yeah. It's compilers. I need to fix them for the program to run at all, so it's not good. Value source. Wait, where are we? What's happening? Compile execute. Okay. So what are we pushing? We're pushing the arguments, right? We're pushing that. No, but this should really be source, though. This should be source, actually. Yeah. And also this one. From source. Oh, that's different. Yeah, that's different. Value source. Push executable. So you are actually, you know what? Oops. You can also add a from here. And say any type. And then say if type of source is equal to location, return from location, oops, source, else if type of source is a value, well, and this is all like in run in or not runtime. This is not in comp time, so it's not actually, you know, taking any time doing this. It's gonna wire up based on the type. And if we get down here, that means we put something in here that's not supposed to be here. So then we can say compiler error, and then we can say type name of type of source. You can also alias the type by saying constant t is equal to type name source, and then you can basically say this instead, and type name is not a valid value source. So if you in comp time would send something in there that's not a location or a value, you're gonna get a compile error. Till what part have we reached? What part of what? There's a lot of things going on. Let's see. Yeah, and then we can say from. Now we can just say from here instead of from location, from value. However, this one is not a known type, so we actually have to say from value directly here, because the thing in here is not like, if we say value, we know it's a value, so then we can use from. But if we don't, if we just do this, we don't know what type it is, but then we can say from value to actually like assert, or not assert, but this would resolve into that type. Okay. Now, here is like before this was a value, so we could just equate it to execute directly. However, now we don't really have that. So what we could do is we could make a function is value tag, and then this would be a tag of value, and we'll return bool. So this would be like it return self equals value and self.value equals tag. So then we're kind of checking both if it's a value and if it's the tag that you put in there. So now we can say is value tag exit code, and there we go. Okay, and then of course we have to say value here now also. Right, this is like the comp time known check here for this stuff. Is value tag exit code. You should make Zig tutorials and YouTube shorts. You can grow your channel faster. Maybe. I'm kind of doing it like piece by piece now. Like people asking questions, and then I just go and like I've been thinking of like I ask a question in Discord about ideas for streams, and I think that maybe because I've been thinking about doing like a stream, like a more like educational thing where we go through maybe some Zig code and kind of, you know, people can ask questions, or like we can go through whatever people want to see. We'll see though if that is interesting, but yeah, something like that. Oh shit, there's 4 errors left and 7 minutes. Pop frame, we push that. I think we should have register or not. No, this is a we have to do from location. So pop frame, we wait, push. I'm pretty sure there's nothing wrong with the instructions themselves, but what are we pushing? Are we storing the stack frame? Okay, so we store the current stack frame so we can use it later, I guess, because then we set stack frame to be stack frame -1. Well, actually, it's not stack frame -1. It's the content of the stack frame -1, which would be the previous stack frame. So this would be from location, I believe, and then init sub register sf -1. And then we want to dereference that. I'm pretty sure. Because it's like, first we're calculating the stack address that we want to access, which should be stack frame -1. So that gets us the previous stack frame, like where the previous stack frame is stored, well, temporarily saved, and we dereference that to get the value from that. So that means that now we should be setting the previous stack frame to the current stack, to the stack frame register. Okay, that's what should happen here anyway. And then we have the destination. This is just gonna be stack counter. So we're setting stack counter to be stack counter -1, which is gonna be this saved stack frame from earlier. So from location init sub register and then we dereference that as well to get the value from the stack. And otherwise we just get the address of the stack thing, right? Okay, and then we have the last thing here, which sets stack counter wait. Oh yeah. So first we're setting it to the current stack frame. So we're setting the stack counter back to the stack frame start, but then we also have to decrease it by 1 because it's essentially popping. I mean, couldn't we just pop here though? But then no, because then we modify the register. Yeah. So we just decrease it by 1. So this would be from location init register. No, init sub register is that. I think we need options there as well. Yeah, except here we don't dereference because we want to decrease the address of the stack counter by 1. So this is essentially just saying that stack counter should be minus equal 1 is essentially what this is doing here. Okay. And then we get the set, we pop the frame for the compiler context, and we check if we have any frames left, I guess. If we do, we set the frame to the previous one. Oh yeah, that's right. So we're modifying the previous frame counter to be updated with a new one. However, this should always be now balanced, so I don't think we need to do this anymore, but it's good anyway. Okay, we still have 4. Okay, there we go. We're out of time. We didn't even get to do the rest of this stuff. But maybe I should just try to continue and fix it because we are because this is like, it's gonna be hard to get into this again. It's like taking so much time just to try to figure out what the hell is going on. I think this needs another, no? Where's the thing? Expected 1 arguments from 2. Oh, I see, there we go. Okay, 3 errors left. If condition, right, so the condition, I mean, I guess it could be, yeah, okay, well, let's just change this to a value source as well, I guess. Now we should get even more errors. From location. Now this is a value, right? Yeah. So actually this would be init, just not init. I think. Yeah. Oh wait, but this is already a location, so we can just use that directly instead. Yeah. And then we can just use from. Okay. Arithmetic source. Damn it. All right. You are a value source, but then this, but then, yeah, and then you. Wait, this is the evaluator, right? Compiler, logical, but now we can use this Xcode. Can we simplify this? I think. Whatever. Let's not do that right now. Same thing here. Two floats. Ooh. Okay, we don't have that. I guess we could add it. Two floats. So if self is a value. No, I would normally use a switch. So it's like switch on self. If it's a value, we'll just return to float from there. Otherwise, actually, let's do location. We return null. So now we should have to float there. Okay, that was all errors in compiler. That's weird because I thought we would get more on evaluate arithmetic. Yeah, because this should be an error here. This is like its value tag instead. Do that, and then oops. Oh man, what the hell happened here? Sometimes it's like it's meditative to do these kinds of refactorings like by hand sometimes. Right. Okay. Was that it? Yeah, okay, so the jump. We get this value source. Now, yeah, so this is the same as the other ones. We just do resolve value source instead. There we go. And now we get this here. Oh. Oh my god. No. Okay, wait. No. This is fixable. Yeah, so, okay, see, this requires a value source, but we have a value. Now, the thing is with these evaluate arithmetic is basically because we want them to work in both comp time and runtime. So, comp time required it to convert it to a value source, although it's not technically necessary though, because we're only working with values if it's comp time. But anyway, it's easy to turn a value into a value source at this point, because I just do dot from, which we just wrap it, so that's fine. Okay. Same thing here, from. And same thing here, from. All right. Okay, we're out of compiler errors. Let's check if the basic. Let's check if this works. No, of course not. Literal type string not yet support. Ah, right, yeah, because I did. Okay, maybe we'll do this one last thing, because we're so close to making this work here. Yeah, I did remove this part, and let's do that. Okay, now the problem here is like the case where we have interpolation. So I'm actually just gonna remove this and say that this is basically unreachable over here for now. There's some kind of issue going on. Oh yeah, there we go. No, unsupported address type. Where the hell does that come from? Okay. Well, okay, this is the only place. Ref instruction register. Okay, well, it could be from anywhere basically. So would have to add better logging to figure out where this is coming from. But if we just go through compile string literals, it could be the execute. Okay, let's just do like exit. Okay, this should compile and run. It's not. It still says unsupported address type. Okay, what if we do like verbose? So we actually do a get a compilation result. That's good. So it doesn't happen through compilation. It actually happens through execution. Wait, why do we have a fork here? What the hell is this? Oh, it's trying to call exit. Wait, I thought I made exit an instruction. Maybe I didn't. Okay, well, let's just do this then. Okay, this does work, apparently. Well, yeah, okay, we just exit, okay. And then, actually, maybe it was return. Maybe this was the thing. No, unsupported state, okay. So yeah, so it was like echo hello that had the thing. So let's actually look at what's happening here. let's look at the instructions first. So now these are surrounded by things here, which means we dereference, which is correct, I would say, because if we didn't have those, it would refer to, you know, the address of this stack pointer basically. So that is good. All right, see you later, Penguin. Let's just analyze this real quick and I'll call it here. So that should all be good. Wait for R, that's fine, right? Yeah. And then exit. This should all be fine. Pushing read-only data, that looks correct. Yeah, yeah. So that all looks correct. So where's the issue happening? Wait for R. Okay, so the issue happens when we wait. Okay. So you have a location, okay? So we resolve the location, okay? So this, to get the value. And what is happening in here? Something is happening. We should get a thread or a closable. And how would we get it? We have to dereference, I think. All right, so let's go to the compiler and let's go to wait. Exec handle is a location that we get from exec. That should be like the register. And actually, we need to kind of... No, we don't need to dereference, I don't think. Okay, so that is that. Then we go back to the evaluator and we see that we're trying to address it, which doesn't work because it's a register or the result register. Right. I mean, it would make sense if wait always wants to dereference. So it's like what we put in wait is like always going to be dereferenced. So this is where I want a dereference function because, yeah, and then we wait on that thing. Yes. So let's add this dereference function, and it's basically just gonna be returning a modified thing. So actually it's gonna be this. And the only thing that changes is the options. Dereference is true. So if it's already dereferenced, then it's like it doesn't actually do anything. But I think this will solve this issue probably. Hey, address, okay, or location, yeah. But also this is weird because we're dereferencing the register R, which is like what we really want to do is just get the value, not dereferencing the value inside. So actually this doesn't make sense either. Like I just want to get the value of the register. That's what I want. So actually this doesn't make sense to do it like this. We just do wait t, and what we will do is say not this. I think we'll switch, and if it's a register, we just want the actual, we just want the value. Yeah, so this is just gonna be that. Okay. Now otherwise, I'm gonna try and do this. Well, actually, otherwise, so we'll return this. If we get down here, we will try this. Okay. So this is just saying that if this happens to be a register and it's the result register, we can just return that directly. Otherwise, you try to make it into like an address. Yeah. Yeah, .abs, that's right. What ID text editor are you using? This is NeoVim. Let's see. Okay, so we don't have more compilers. Oops, let's go back to. Well, let's just do this one, I guess. Oh, there we go. It works. Wow. Wow. Cool. So it does work. Okay. What about the other stuff? Do you work? Probably not. No. Access a unit, but okay. So I won't fix everything, but at least we are on our way to kind of like, because what I'm doing right now is like I've done a lot of changes to like how we deal with addresses and dereferencing and all that to make it more less spaghetti and more, you know, more consistent, I guess we could say, so that we can kind of refer to things without having to go through the whole code base to understand what's going to happen. So now it's kind of, yeah, we can kind of logically see what's going to happen, hopefully. And but yeah, but that's going to be it for this time. I'm out of time right now, so actually I have a couple of people in here I can raid somewhere. But yeah, that's gonna be it for me. So have a nice day, and I'll see you later. I'll just find some kind of stream. Also, no, not also. Forget that. Let's see where we can send this. Send you off to here. On the Twitch side, that is. I'm not sure if the other place has rating. Coding. Oh, this looks cool. All right, let's go. Or, yeah, I'm not sure what's going on here. But I'll send you over here. All right, see you later. Bye bye.